zeros. So first of all, can anyone tell me when it says what are the zeros, what are we finding? X-intercepts, right? Okay, so first of all, we have a linear piece multiplied to a quadratic piece. Now, some people want to start multiplying this together, but then how do we solve it? It's going to be miserable to solve it, right? We wouldn't really know how. So don't we technically, anytime we're trying to find the zeros, the x-intercepts, don't we, if possible, don't we want to have it down to its linear factors, meaning degree 1. So right here is a linear factor, and then we know, okay, if we have a quadratic, we can possibly solve it by factoring. Solving it would be finding the x-intercepts. So let's first of all, let's get this into its linear factor form, or factor form. So my a value is in front of x squared, it's 1, my b value is 5, my c value is negative 6, right? So we try to factor it. Well, multiplies to be a times c, and adds up to bb. So a times c would be what multiplies to be negative 6, and b is 5. So you're listing out factors of 6, 1 times 6, 2 times 3, correct? Any others? No. Okay, so let's figure out which ones could add up to be positive 5. So first of all, could 2 and 3 add up to be positive 5? Yeah, but that doesn't multiply to be negative 6, right? So there's no way we can make it work in both boxes here. So now 1 and 6, could it add up to be 5? Yes, but one of them would have to be negative. Which one for this positive 5? Negative 1. Now let's check. Does negative 1 times positive 6 equal negative 6? And negative 1 plus 6 equals 5. So it works in both cases. So we can factor this. Now because our a value is positive 1, we can quick factor it. So just this piece became, you put your binomial, multiply together, you put in your x, right? And then you insert those factors. So it was negative 1, so minus 1, and it was positive 6, so plus 6. Now guys, this is no different than this. They're equal. This is factor form, this is standard form. So why did we factor? Why did we factor? What's the whole point of factoring? So we can what? Find the zeros. How do we do that? Set each of them equal to 0. So the zero product property rule says if you have linear factors being multiplied, you can set each linear factor equal to 0 and solve. So we have x minus 1 is equal to 0. We have x minus 1 is equal to 0. We have x plus 6 is equal to 0. Then it's just algebra, solving for x in each case, correct? So we'd add 1 to both sides, so we get x is equal to 1. We'd add 1 to both sides, so we get x is equal to 1, right? Subtract 6 from both sides, so we get x is equal to negative 6. So our three zeros are 1, 1, and negative 6. So couldn't we have said we have x is equal to 1 with a multiplicity of 2, meaning it happens twice, right? And that means the 0 bounces and goes back up on that value. So does that make sense? It's going to touch down at 1 and go back up automatically. Okay, and then it crosses at negative 6 as well. Is everybody comfortable with that? Okay, sweet. Now, I'm just going to ask you a besides the point question. Looking back up here, what degree is the polynomial? What degree is it? I know you know this. What degree is my polynomial? Say it. Huh? This piece is first degree. No, this piece is second degree. Wouldn't it be third degree? Isn't this just a polynomial? It's just half partly factored, guys. So we multiply it together. The highest degree is what you name a polynomial on, right? So wouldn't its highest degree be 3? Does everybody understand? Okay, awesome. Okay, let's get going with today's lesson. So remember this unit, we've been in sequences and series. You should have a notebook out taking notes, okay? So we've been in sequences and series. We've only dealt with sequences so far. So recall, a sequence is an ordered list of numbers with a pattern. This is an example, 8, 6, 4, 2. What's happening from one term to the next? Good, it's going down by 2. We're subtracting 2 to each term. Then recall, a recursive formula to find any term in a sequence is written in terms of the previous term. So recursive formula is just a formula to find any term in a sequence, but a recursive formula is a formula written in terms of the previous term. So this is just an example of a recursive formula. A sub n minus 1 plus 2. That would mean to take the previous term, because that just means previous term, and we'd add 2, right, everybody? So that's an example of a recursive formula. And then we also learned you can write an explicit formula for a sequence, which an explicit formula is a formula to find any term in a sequence, but this time it's written in terms of n, not previous term, but n. So a sub n is equal to n plus 2. That would be, n is the term you're on, right? So n is the term you're on. So for example, a sub 1, our n value would have been, what? 1, right? Isn't n the term you're on? Yep. Okay, awesome. So this is an explicit formula. Now I do want you to remember, explicit formulas are a lot easier to use to calculate any term of a sequence. Because if you use a recursive formula, don't you have to know the previous term? So if I said find the 100th term, wouldn't you need to know the 99th term if you were going to use a recursive formula? So if you didn't know that, you'd want to use an explicit formula over a recursive formula. Because remember, each sequence can actually be written as both. Okay, so we learned this last time, an arithmetic sequence. So we focused last time on arithmetic sequences. So with an arithmetic sequence, the general formula was an explicit formula to find any term in a sequence. So we could write our own formula, explicit formula, for each particular sequence. But in general, this formula will always work, right? So if you didn't know, because some of them are harder than others, you could not write your own, you could just use this, because this will always work for an arithmetic sequence. This is an explicit formula in general. So we learned this last time. A sub n is equal to a sub 1 plus n minus 1 times d, where n is the term and d is the common difference. So let's do this one. We're going to write an explicit formula, and then we're going to find the 40th term. So first of all, let's write the explicit formula. Instead of writing our own, let's use the general formula for an arithmetic sequence. So we know that it's a sub n is equal to a sub 1, which is first term, right? In this sequence, what's my first term? So we'll do 8 plus, comma, n minus 1. Because n is the term we're talking, and then what's our difference? So we're going, let's be careful though, let's see, what's our common difference? Don't you have to take the term that comes before the term before it? So we'll do 6 minus 8. Negative 2, what's 4 minus 6? Negative 2, so our common difference is negative 2. Is everybody comfortable with that? Okay, now I'm asking you to find the 40th term. So there's our explicit formula, we can use that to find any term in a sequence. So now are we finding a sub 40? That'd be the 40th term, right? So we'll have 8 plus 40 minus 1 times by negative 2. Let's type it in. Go. You should all practice typing it in. So 8 times, parentheses, 40 minus 1 times by negative 2. A sub 40 is equal to negative 624.
That's not right, Adam.
I did 8, yeah, you're right. I typed it into my calculator wrong. What did we get?
Hold on.
So I didn't hit a plus sign on my, well I did, but my calculator didn't hit it. So let's see if you guys are right. You said negative 70, right? Correct. Negative 70. Were we all able to get that, or did we have any mistakes like I typed it in wrong the first time? We're all good? Okay, awesome. So that was just a practice. So today is 8-3, and now last time we focused on arithmetic sequences, today we're going to focus on geometric sequences. So a geometric sequence is being built by multiplying each term by a constant value. So you're going to take each term of the sequence and you're going to multiply by a constant value between each term. So a geometric sequence will have a common ratio. So instead of a common difference like arithmetic, which makes sense, addition and subtraction, right? With multiplication, you're going to be doing division, right? So a geometric sequence will have a common ratio from one term to the next. So just like in arithmetic, we have a common difference, in geometric, we'll have a common ratio. Now, common ratio means division. Ratio means division. So just like with subtraction of terms, you've always got to start with the term that comes before the term above it. So let's figure out the common ratio of this example here. So first of all, we're asking, what are we multiplying by between each term? That would be their common ratio. So you can take it by dividing 4 divided by 2. What do we get? 2. What's 8 divided by 4? 2. Do you guys see how I'm doing the term that comes before the term above it? What's 16 divided by 8? 2. So what's my common ratio? 2. Good. We were multiplying by 2 to get from one term to the next. Okay, let's do this one. So this is geometric, So we're asking, what are we multiplying by each time to get from one term to the next? You can find that by finding the common ratio. You should have a common ratio. So you have to make sure you do this term divided by this term. So what's 3 divided by -1? -3. Let's see if it's the same. If it's geometric, it will be the same between each term. What's -9 divided by 3? -3. And what's 27 divided by -9? -3. So aren't we multiplying by -3 each time? So our common ratio is -3. Questions on that? Okay, awesome. All right, so we're just going to get right to it. So, just like with an arithmetic sequence, there is a general formula to find any term of a sequence. We can also use a general formula for geometric sequences. So, on the day 1 of this unit, we were writing our own. Now, you won't have to write your own anymore. In fact, with geometric, it can get pretty hard. Remember on day 1 how I had you skip a few? It's because they were extremely hard to figure out without knowing this general formula. So now, if you don't know how to find the formula, you'll just use the general formula for the geometric sequence. So, a recursive definition, we never really use it, so I don't even know if you need to write it down, but in general, a recursive definition for a geometric sequence is this. A sub n is equal to A sub n minus 1, which means previous term, which makes sense. A recursive definition is always written in terms of the previous term. So you'll take the previous term and multiply by the common ratio. Which makes sense, right? Like in these ones. This one, like if we were to write our own formula, it'd be pretty easy, right? Previous term times 2. Previous term times 2. Does everybody understand that? Okay? Now an explicit definition is this formula, and you'll want this down. So explicit is the one we like to use if we're trying to find any term of a sequence, because we don't need to know the previous term to find it. So here's the explicit definition. To find any term in a geometric sequence, A sub n is equal to A sub 1, which means first term, times by r raised to the n minus 1. So r is the common ratio. So from one term to the next, that's the common ratio. And then n minus 1. N is the number of term you're on. So this formula in general you'll use, and you can use it to find any term in a sequence. Okay, so get that down, you'll need it. I refer back to it all the time. Okay, so if you can't figure out your own, you could write using this general formula for explicit of a geometric sequence. Okay. Did everybody get that written down? Do I need to go back? Okay, here's our first example. It says, is the sequence geometric? If so, what's the common ratio? And then it's asking us, what's the 18th term? So let's answer this in pieces. It says, is the sequence geometric? If it is geometric, we'll have a common ratio. So we're going to do 6 divided by 3, 12 divided by 6, 24 divided by 12. So yes, it is. And our common ratio is 2, right? Ratio means what did you multiply by each time to get from one term to the next. Is everybody comfortable up to here? Now it says, what's the 18th term? Now, we don't want to have to go through and find 18 terms of this. So let's just quickly write an explicit formula, and then we can just go through and plug in 18. So, here we go. We know that the formula is this for an explicit definition, right? Okay, so let's write it. So we know that A sub n is equal to A sub 1. What's our first term? 3. What was our common ratio? So 3 times 2 raised to the n minus 1. Isn't this the general formula? Yeah. So now we don't only want n, we know that we want the 18th term. So we want A sub 18. So n is 18. So we'll do 3 times 2 raised to the 18 minus 1. So now we'll just type it into our calculator. Go. Now make sure when you type it in, let's all practice typing it in, because it depends on how new or old your calculator is. So we have 3 times 2 raised to the, you need to put this in parentheses. We have 18 minus 1 all in the parentheses, or you could just type in 17, right? Isn't 18 minus 1 17? So I'm just going to go 18 minus 1, close my parentheses. You get 3, 9, 3, 2, 1, 6. 393,216. Did we all get that? Yes. Yeah. Which it does get, I mean, it is pretty big. This is a lot different than arithmetic. We're multiplying each time by 2, right? So isn't it just getting bigger and bigger? We're like doubling it each time, right? So it could be that big for geometric. Questions on that? Okay. So let's do another one. So is the sequence geometric? If so, what's the common ratio? So let's figure out here. So let's go. 15 divided by 10. 1.5, right? Everybody?
Yep.
And then 22.5 divided by 15. 1.5. And if you keep doing that, this divided by this is 1.5. Therefore, yes, we do have a common ratio. And it's 1.5. Everybody comfortable with that? So now we're finding the 18th term. So we're going to be doing, I'm going to write an explicit definition here. So we know it's a sub n is equal to a sub 1, which is the first term. So 10 times by our common ratio, which is 1.5 raised to the n minus 1. And now we're talking 18th term. So that'll be a sub 18. So we have 10 times 1.5 raised to the 18 minus 1. So 10 times 1.5 raised to the, so you get 9,852.6. Are we all good? Okay, so we're ready to go. Okay, do 1 through 18. So on number 16, if you went through and found the 10th term, many of you got this as an answer. 1.69 and then it was e to the negative 5. So that means times 10 to the negative 5, right? So now, if you try to change that back to a fraction, your calculator won't do it for you. But what if I said you must write your answer as a fraction? Then you're going to have to think through this one a little bit. So let's think about it. What was the equation I used to get this answer? Wasn't it 1/3? That's our a sub 1, right? Our common ratio was 1/3 raised to the n minus 1. So if we're finding the 10th term, that's 10 minus 1, so that's 9, right?
Yep.
Now, let's think about it. Isn't that just 1/3 times 1/3 times 1/3? That's two. So this is this 1/3, and then isn't this 1/3 9 times?
Yep.
And so on, 9 times, right, everybody? So when we multiply fractions, don't we just multiply straight across?
Yep.
So a bunch of 1s being multiplied on top is going to be 1, right?
Yep.
And on bottom, how many 3s are we going to have? 9 right here, and then 1 more, right? So 10. So we're going to multiply 3 together 10 times. Or that's the same thing as 3 raised to the 10th power. Because doesn't that mean 3 times 3 times 3 10 times? So type in your calculator, 3 to the 10th power. You should get 59,049. This would be the answer I'd want. Okay? Questions on that? Okay, awesome. Let's move on. Okay, guys, so I need you to pay really close attention so that this can hopefully make sense to you. Okay, so in a geometric sequence, there is the same common ratio from one term to the next. We just learned that. Between each term, we're going to be multiplying by the same term. So now it's asking us, find the missing term in the sequence. So we did this differently with arithmetic to geometric. So this is how you could think through it algebraically, and this is actually how the formula comes out. So let's think about it. Don't we know, I'm going to call this x because we don't know it, right? Don't we know if we're told it's geometric that this divided by this will be equal to this divided by this, right? Want to be the same no matter what. Okay? So isn't that a true statement to say x over 48, this divided by this will be equal to, because the ratio from one term to the next will be the same, is equal to this divided by this, 3 over x. Isn't that true? And that is the formula, right there. So now we'll just solve for x algebraically. So wouldn't we want to get rid of the fraction, so we would cross multiply, right? So we multiply both sides by x, but won't it divide out over here? Multiply both sides by 48, but won't it divide out over here? So we have x squared is equal to 40, oh, hey, let me use that calculator real quick. 48 times 3. 144. Now we're just solving a quadratic at this point, right? This one's an easy quadratic, then we square root both sides.
Yep.
So we have x is equal to 12 and?
Yeah.
What squared equals 144?
12.
12. What else squared equals 144? Negative 12. Isn't negative 12 squared also 144? That's why we never forget the plus and minus, right? Right? So this could be plus or minus 12, right? Everybody, do you understand that you have to put both? Okay, because we could have been, once again, 12 divided by 48. We could have been multiplying by 1/4, or we could have been multiplying by negative 1/4. Either one. So x is plus or minus 12. Questions on that? Okay, so then this is the formula, guys. I mean, it is, the way we just got through it is the formula. So it says, if you have, so it says in a geometric sequence, the geometric mean, which is what we just did, the geometric mean is the middle term between the three consecutive terms. So if you know x and y, you can find question marks because you'll do question mark over x is equal to y over question mark. Then you cross multiply, which would give you question mark squared, right? Is equal to x times y. Then you square root both sides, so that's why it'd be the square root of xy. That's the formula, the square root of xy, but that is y. So I don't want to have to memorize a formula, so I just set it up every time. Because that is what you're essentially going to do, right? Okay. So let's do this one. So, it says find the missing term in the sequence. Once again, I don't have anything memorized because I don't want to have to memorize formulas. I say, okay, if it's geometric, then I know between each thing the same thing's being multiplied, or we will have a common ratio. So this is x. So I'm doing x over 5 will be equal to this divided by this. So we'll be equal to 2.8125 over x. Then we're going to cross multiply. So we have x squared is equal to 5 times 2.8125. 14.0625. We won't round till our final answer. We square root both sides of the equation. So we get x is equal to second square root of second answer. And you get 3.75, but you can't forget the plus and minus. So plus or minus 3.75. We don't know. We can't determine. It could be plus or it could be minus. Questions on that? Okay, finish the front. Number 9 I'm doing with you. It says, identify if each sequence is arithmetic, geometric, or neither. So if it's geometric, your sequence will have a common ratio. If it's arithmetic, then, I'll fix that. If it's arithmetic, it will have a common difference. And then neither would mean there's not a common ratio or common difference. So this is actually, I don't know why I wrote number 9, but number 32. So this is number 32. Okay? So here we go. We're determining if this is geometric, arithmetic, or neither. So first of all, I'm going to start out to see if it's geometric. So I tried dividing. So 3 divided by 9. 3 divided by 9, guys. 1/3. 1 divided by 3. 1/3 divided by 1. So they have a common ratio. Therefore, it must be geometric, right? We're multiplying by 1/3 each time. So we'd say geometric. So we're multiplying by 1/3 to get from one term to the next. It says find the next two terms. So since it's only 2 more terms, I'm just going to multiply each of those by what we would multiply. So it's 1/3 times 1/3. Multiply straight across. This should be in your head.
2/3.
No, what's 1/3? We don't add. What do we do? 1/9. We multiply straight across. So 1/3 times by 1/3 is 1/9. Now this should be in your head. What's 1/9 times by 1/3?
127.
127. We found the next two terms, okay? Okay, next one, number 38. Right and number 38. So you'll determine on the rest of those if they're geometric, arithmetic, or neither. Okay, number 38. It says write an explicit formula for each sequence. And then generate the first 5 terms. So first of all, an explicit formula we learned in general is this, right? So let's write it. We're given a sub 1. So we know that a sub n is equal to a sub 1, which is 3. Our ratio is -2, raised to the n minus 1. There's the general formula for any term in this particular sequence. To generate the first 5 terms, that would be a sub 1, 2, 3, 4, and 5, right? So our n is 1, so we plug in 1. Is everybody good with that? So you plug in 1, so we would have 3 times -2 raised to the 1 minus 1. So it's going to come out to be 3. Calculate it in your calculator. You get 3, right? Okay, this next one I'll pause. Okay, let's do this next one. 3 times negative 2 raised to that we're plugging in 2 for n. So 2 minus 1 is 1. So that's 3 times negative 2. Negative 6, right? Are we good? Okay, so then plugging in 3. So you'll do 3 times negative 2 raised to the second power, because 3 minus 1 is 2. So that'd be 12. So are we multiplying by negative 2 each time? So I'm going to finish off by not plugging in, but saying, okay, I can say I'm multiplying by 2. It's geometric, so we can keep doing that. Then it's negative 2, right? Sorry, negative 6 divided by, so 12 divided by, multiplied by negative 2, and then multiplied by negative 2. Okay, good. Question on how to do those. Okay, so this is all that's required. I'm not making you do all of the back, just these. So you're doing 32 through 41. That's it.